Okay, so as we continue on in lesson 2.4, sometimes, typically what we do is we undo the addition or subtraction first. Today, when we see a problem like this, we're going to undo that division first, and then we'll go and worry about other stuff. Okay, so when we have a problem like number 4, this is like a carry-on from yesterday's notes, when we have x plus 5, it's in a numerator of a fraction. So the part that has the variable in it is in the numerator, and then that's being divided by something. We're going to undo that dividing by 2 first. That's going to be our first move. So we're going to undo the dividing by multiplying by that 2. So we show multiplying both sides by 2. We're going to undo the dividing first. Because what happens is what we really can do is we can make this 2 into a fraction by putting it over 1. So now we know that when you have a fraction times another fraction, what you can do is you can cancel those 2's then. They divide out of an upstairs and they divide out of a downstairs. We can just kind of like eliminate them. And that was our goal, is to get rid of that 2. So we now really have left x plus 5 on the left side. Do we have to switch to the inequality symbol? I think a lot of us forgot to keep asking ourselves that question yesterday. Whenever you multiply or divide by a negative, you have to switch it. Did we multiply by a negative? No, so we don't have to switch it, do we? And 2 times 3 is 6. Okay. From this point on, it looks pretty easy, doesn't it? What do we do next? Subtract 5 from both sides. X is now by itself, and we did a subtraction, don't have to worry about symbol change, and we end up with x is greater than 1. That's our algebraic solution. And then when we graph it, go ahead and do that because you guys are really good at that now. Is one part of the solution set? Is one part of the solution set? No, so that means we do not shade the circle in that 1, do we? But anything greater than 1, so anything heading to the right of it on the number line is a solution. Now again, here's another thing that I don't think some of us are just taking, it doesn't take very much time. Look at the integer neighbor in the shaded region and make sure that it makes the inequality true. So we would put 2 in for x. Is 2 greater than 1? True or false? Yeah. True. It makes it true. So I'm feeling pretty good about my shaded region. Okay. Any questions? Okay, and number 5, what would be our first move then? What would be our first move in this one?
Times 3.
Yeah, multiply both sides by 3. Okay, so we'll multiply the left side, the 1 minus 2n over 3, and we'll multiply the right side by 3. So here's what I'm going to box what I'm multiplying by. Everything else basically stayed the same right now. So remember, this is like we can put it over 1 to make it into a fraction on the left side, because then we can cancel those 3's. And we have 1 minus 2n left on this side. Do we multiply by a negative? No, so we don't have to switch the symbol, do we? What's 3 times 7?
21.
21. Okay. Now, this is where I think many of us, I caught this on a lot of papers yesterday, that when instead of it starting out with a variable term, it starts out with a constant subtracting a variable term, then people thought they could read it as 1 was being subtracted on this side. We cannot read subtraction backwards. So the thing for us really to do is change this to add, and the opposite of 2 is negative 2. Because then we can read it backwards. Then we can say, oh, we got a 1 being added to a negative 2n, or we can say we have a negative 2n being added to 1. We can read it either direction. We cannot do that with subtraction. So what would we do to get that 1 out of there? Because if we want that negative 2n to be alone,
Subtract it.
subtract it. So we're going to subtract 1 next from both sides. So we'll subtract 1 from both sides. And it's a negative 2n that is left. We are subtracting. We don't have to worry about reversing the symbol. 21 take away 1, 20. Okay, what's our next move?
Divide both sides by negative 2.
Divide both sides by negative 2. So negative 2n is going to get divided by negative 2. The 20 is going to get divided by negative 2. Hands off those calculators. We don't need them. Over here, our negative 2's cancel. We have just n. What do we have to do?
Switch the sign.
Switch the sign because we divided by a negative, didn't we? What's a positive divided by a negative?
Negative.
Negative. And how many 2's are in 20? 10. So n is less than or equal to negative 10. So notice there were 2 times we multiplied in this problem, or we multiplied or divided in this problem. First we multiplied, so we had to stop and think, did we multiply by a negative? And then in the end we divided and we had to ask ourselves, did we divide by a negative? And then just like happened in the last one, our variable is on the left side, which is a friendly side. So it's going to make it hopefully a little easier for you to graph. Make sure the integer neighbors are in their correct location. Don't misplace them. Is negative 10 part of the solution set?
Yes.
Yes, it is, because of the equal to bar, so we shade it in. We say negative 10 will make the inequality true. How about, what direction should we shade?
Left.
To the left. And we take the short amount of time it takes to take that integer neighbor that's in the shaded region, negative 11, and put it in for n and see, is negative 11 less than negative 10? Yes, it is. So we're feeling pretty good about our shaded region. So those are, a new type that you're going to see in your homework today. Anybody have questions? Okay, let's go to the back side. I think we just got one more to practice here. Sometimes you will need to simplify first before solving. So in other words, simplifying means you're only going to do it where it needs to get done. You don't have to do the same thing on both sides.
So you could times the negative 4 by, times the 2 by negative 4 and then minus, put the minus sign down, and then negative 4 times x.
Yeah, now we have to be careful though. What is best to
Oh,
do?
you would have to make the positive, make it a negative x.
Yeah, let's change this. Let's rewrite it so that it is add the opposite. Because when we're multiplying and we have subtraction and we have negative signs involved, we can get ourselves into trouble by not changing subtraction to add the opposite. So this does become a plus a negative x. And we need to get in the habit of doing this because some of the stuff that we're going to keep moving into, it's going to get a lot, it's going to work better for us if we do. And then is less than or equal to 8. So all we did is just rename it right now so that when we do our simplifying, it will go better. Okay? So we're not ready to solve this yet. We're going to simplify it first. What do we have to do? What's that called? To get rid of the, distributive property. To get rid of the parentheses, we've got to do distributive property. So we're going to take negative 4 times 2. There's one of our multiplications. Bring down our plus sign. We're going to take negative 4 times negative x. There's our other multiplication. And then just bring along the rest of the inequality. So we're simplifying right now. Multiplying that negative 4 times both of the terms in the parentheses. A negative 4 times a positive 2. Negative times a positive is a negative, and 4 times 2 is 8. Plus, now we have a negative 4 times a negative 8. X. A negative times a negative is a positive, and 4 times x is 4x. Okay. Is there any other simplifying we can do? Is it ready to solve now? Okay, now we're ready to solve. So we'll say ready to solve in our notes, just so we know that what we were doing before is what it said up above. You might have to simplify it first. So now it is ready to solve. Okay, what are we going to do?
You would add the 8's opposite.
Yeah, you would add negative 8's opposite, which is positive 8. Yeah, so we're going to add 8 to both sides. And now we have 4x is less than or equal to what? 16. Okay? And our last and final move is?
Divide both sides by 4.
Divide both sides, not by 4x, just by the 4, because it's the x that wants to be alone. It says get the 4 out of there. Don't try and get rid of me. Just get rid of that 4. And we get x is less than or equal to 4. And we should be ready to graph it. And again, it won't cost us much if we just take the time to say the integer neighbor that's in the shaded region, if I put it in for x, does it make it true? This is 3 less than 4. Yes, so we're feeling good about our shading also. Okay, any questions on this one at all? Sometimes we're going to have to deal with the fact that there's that variable is part of a fraction, and we're going to get rid of that denominator by multiplying. Other times we may have to simplify before we can solve.